So today we're going to be looking at some differences between experimental and some theoretical probabilities, and we'll even perform our own experiment and then figure out some probabilities. But we're using this word probability quite a bit because this is the probability unit. A probability is just the chances that something happens. Bam. Probability. The chances that something happens. For example, the chances that a boy or a girl walks through the door next, or the chances that Loyola Chicago goes to the Final Four. Which, well, yeah, right now it's 100%. That's good.
They already Final Four.
But now we may want to figure out the chances that Loyola Chicago wins the whole tournament.
It's a 25%.
Or we looked yesterday in lab at the possibility that UMBC was going to beat Virginia, but we manipulated it so it was really easy. Or what are the chances that someone that talks a lot during class will not talk? Very low, right? All right, so then we got these two different types of probabilities. One is experimental and one theoretical. Let's look at theoretical first. So we're going to define theoretical probability that the chances something will happen without doing anything. So we kind of have to analyze what we're using. Sometimes we spin things, sometimes you roll things, sometimes you flip things, sometimes you kick things, sometimes you punch things, but the last two are more out of anger than anything. So don't do those things, okay? So then yeah, the theoretical probability of those is high. But kicking and punching I don't think is really allowed unless it's on the ball, which would be kind of weird if you punch the ball, right? That'd be kind of a fumble, right? So if that's the chances of something happening without doing anything, then the experimental probability is the chances something will happen by doing something. So experimental probability is the chances something will happen based on what has already happened, usually an experiment. So experimental probability is where you actually do the experiment. Theoretical probabilities is where you don't actually do the experiment. So it's pretty nice. Here's a nice thing about probabilities, you guys, is this is where math people really, really get to manipulate people's minds. So just so you guys understand, you guys are going to see this letter a lot in this unit, P, which does not stand for a color, even though we did the drawing of the boxes. This P stands for the probability, and then it's followed usually by some set of parentheses like these. So inside the parentheses, it will indicate the probability of something happening. For example, for us, maybe it was the probability of drawing a purple. And then we can determine the experimental or even the theoretical probabilities. Okay. Now, if we were to roll a number cube or some kind of dice, it may have a number inside, like a 2. So this would be, what is the probability of rolling a 2? Which again is just really asking, what are the chances that you roll a 2 with a dice? Another one would be something like flipping a coin. What are the probability that you get tails? Now it depends on the experimental and theoreticals for all three of these. If we're trying to find theoreticals, then for us the poiples ended up being 1 out of 10. The theoretical probability of rolling a 2 is 1 out of 6, and then probability of tails is 1/2. Eventually what we're going to do is combine them though, and you'll see what is called a compound probability, which would indicate maybe, for example, the probability of rolling a 2 and then maybe tossing tails. Now yeah, if you wanted to compound it further, you could say 2 tails per poiple, and then we would be combining these. Alright? Now we won't do a lot of theoreticals or experimentals on those compound probabilities. But we will do some theoreticals on those. So just so you guys understand, this is a very common notation that we use for probabilities, and you will see this not only on the homework but also today's classwork as well. So with me right here, I have this basket, and inside the basket I have many boxes, 10 specifically. Oh, I'm not using that one. So I've got 10 blocks, and we're going to go through, everyone's going to choose a block, and then we're going to put marks down to see, keep track of what color we pull out. After we pull it out, we're going to put it back in. And we'll just keep track of that as we go. So we got 5 colors. We've got the most spectacular color and the most powerful one of all, the red.
Purple.
Then we have purple, green, yellow, and then perverted purple. It's too long to spell
Blue.
and too evil for people like that.
Blue.
All right, looks like you guys choosing lots of reds. Looks like you guys do not like choosing perverted purple, which is a good choice.
Jump out the block.
Good choice not to choose perverted purple. So, all right, so let's look right here. Now, what I want you guys to do is make predictions. We know there's 10 blocks, right?
There's 0
Well, I told you there's 10 blocks. I'll show you that there was 10 blocks, okay? Here's what you need to do now
like a blue one.
is you need to go through and predict how many of each color you think there is in the basket. All right. Does anyone need more time to make their predictions? All right. So does someone want to tell us what predictions they have made, please? That's not perfect, but it's because I forgot to put a line right there. All right. So for this prediction, right, we've got a total of 9 right count, but we know for sure that there has to be 10 right there. So let's adjust this just a tiny bit. That's good. Now this shows a total of 10, which is good. So there's our third one. What about the next one? All right, this is good to see. No one thinks there's any perverted purpleness in there. That's good. We got to get rid of all of the garbage, all of the filth, and the evil out of the basket, right? All right, we need one more, though. All right, now that we have these, that's... yeah, there's only 9, so we need one more on there. All right, that's good enough. So, hopefully you guys, how many guys got something pretty close to what we have up at count? No, so let me ask you guys this. What were you basing your predictions off of right account? So yeah, you guys make some good points right there. There's a lot more reds than there are of either of the other 4 colors. The purples and greens are pretty close, so some of you guys matched them, some of you guys had them offset a little bit. And then the yellers, for the most part, you guys said that this was the leastest of them because of the value that we got after performing the experiment, okay? So before we look at the actuals, because you guys are so excited, let's figure out how many total times did we draw? How many total draws did we have, right account? All right, so I have 37 total draws, right account. And we can see that, how many reds did we get? We got 26, that's what I count right there. How many purples?
4.
Greens?
5.
Yellers? 2. All right, now that we have these, let's figure out some probabilities before we look at the actual amounts in here, okay? So, based on this experiment, and we looked at the probability stuff, so if I said I wanted to find the probability of red, what would it be?
26%.
No. Yeah, very good. It's 26 reds out of 37 total drawers. Right account, okay? Now that's the fraction. Let's figure out what the percentage is. So rounding to the nearest percent, I got 0.702 or something like that. So we're going to say that you get about 70% chances of red. Now let's look at purple. Yeah, so yeah, let's look at that. It's 4 purples out of 37 draws. So changing this to a decimal. So that came to 10.8%, which I'm just going to round to 11%. Right, what about good old green? So I got 13.5%, which again I will round to 14%. Now what about the yeller? So as a fraction, we got 2 out of 37. Now let's look at the probability of good old perverted purple, which no one seems to like anyways. Well, we got 0 out of 37 draws. So we'd get 0% on that, right? All right, now usually, and you guys did a good job of estimating because we haven't learned this yet, but looking at this, at least the percentage of red, since it's 70%, I would expect to see 7 total reds in there, which, yeah, some of you guys got. And since the purple and green were closer to 10%, I would probably have chosen 1 for each of those. And since you can't have less than 1 for the yellers, I would round this up to 1 as well. So that's what my prediction would be based on these percentages right here. But let me ask you this. These probabilities that we found, are those theoretical or experimental? That's very good. They're experimental because it's based on an experiment that we have already done. So when we find the actual probabilities, which we will do, what are those going to be based on? What type of probabilities are those?
Theoretical.
Those are theoretical because you can make predictions on those based on those numbers without actually doing the experiment now. All right, so this was what was actually in the basket, okay? Now, this is different than what you would expect, and asked, how is it possible that we got more purples and greens when there was actually more yellers in the basket? How is that possible? Maybe the yellers were on the bottom, and if you guys weren't really digging into the basket, you may not have caught those, right? Yeah, why aren't there any perverted purples? Because there never was any. Because we wanted to avoid all of that perverted purpleness. Well, this is the thing with experimental probabilities, and actually doing an experiment, is it's not always going to be perfect with the way that you think it may turn out, especially after performing the experiment like we have done. So usually it'll be a little bit off, and for the most part, you guys were really close. Usually you guys were within 1 for all of these. Some of you guys got these exact. The one everyone seemed to got perfect was that there were 0 perverted purples, just like we like it. So now what we want to do is figure out, because we got the experimental probabilities, let's go through and figure out the theoretical probabilities. All right, let's start with the red. Now, theoretical probabilities is based on what is actually in there, meaning we didn't have to draw anything, but we can figure out the probability of drawing it just based on that information that was already, well, it wasn't given to us, but it is now. So, what is the theoretical probability of drawing red? Well, how many reds were in the basket? 6. Out of how many total? 10 total. Now you could simplify this if you want, but let's look at the percent. If we change this to a percent, you'd get 60%. Bam. So there was a 60% chance of us drawing red, whereas the experimental probability was 70%. So what is the theoretical probability for purple? Very good. 1 purple in the basket out of 10 total blocks gives us 10%. So it looks like green would match that, right? There was 1 green out of 10, which also is 10%.
Wait, why is it theoretical?
We could have figured these out before we started drawing out of the basket, which is what makes these theoretical. All right, next up is good old yeller. All right, so we got a 20% chance of yeller, theoretically. And then finally, perverted purple. Thank goodness. We got 0 out of 10 blocks. No one likes that garbage. And so we made it 0%. 0% theoretical probability. The chances you ever draw a perverted purple out of that basket will always be 0.
Because it's blue.
All right. So this means that theoretically, before you put your hand in the basket and draw one out, you have this chances of drawing these specific colors from the basket, which is what makes these theoretical probabilities. So we have that formal definition on your papers, but actual probability is how often something happens divided by how many tries or attempts. That's why when they look at free throw percentage or even 3-point percentage or field goal attempts in basketball, perhaps they may be looking at if you make 3 attempts out of 12 in a game, then they'd say you got a 25% chance or a 25% free throw shooting percentage, or you. All right, so that means that that person would have a 25% chance of making the next free throw. That's why back when people like Reggie Miller were playing, at the end of the game, if it was close, they would hand him the ball so that people would foul him because he had a higher chance of making a free throw than most of his teammates would. You're a teacher in a 7th grade math class and you want to create an experiment for your class with red, yellow, and purples in a bag. You want the theoretical probability of drawing a red to be 1/4, and the theoretical probability of drawing yellow to be 1/4, and the theoretical probability of drawing a purple to be 1/2. Now what we have is 120 marbles, so how many reds should be in the bag? Alright, I'm going to show you guys this a little bit different than the way you've explained it, even though you've done a great job explaining it, okay? So let's look at the way he showed it. So, and that's good. I mean, if you're looking at this and saying, well, there's half of them are purples, then you know that half of 120, right? 120 just divided by 2 is a half of it. Gives us 60 purples. And then you know a fourth is a half of a half. So when we ask for how many reds, we just do 60 and divide that by 2, which is 30 of the reds, which makes sense then that there would be 30 of these yellers. Because yellow doesn't show up very well on the board. So anyways, so that's one way to do it. Another way to do it is to use a very common method that we have seen in a previous unit called a proportion. We know that, for example, reds, let's just look at the reds. For the reds, there's 1 red out of every 4 total marbles. And this should equal some number of reds out of 120 total marbles. Now you could solve this by using good old fish method. 120 times 1 divided by 4 is x, and that gives you x is 30. Now you'd use the same method on the yellers and the purples, but the method that you used is fine as well. So choice is kind of yours in terms of how you wanted to go about it. But all of this is good.